squared plus 1, y prime, xy. Did I write that right?
No, I said, which one did I say?
You said, oh, you said 4, and I wrote 3. Doesn't that seem logical? How's that? They're so similar.
Oh, I don't like the way that looks.
Alright, so this is separation of variables, because that's what this section is. It's also the only technique we have for solving differential equations other than stare at it till you see the right answer. It's familiar, and that's the first two techniques you learn, or technique you learn for integration. Stare at it, and you learn use of. That's where my high school kids are at. Like, alright, you either have to stare at it and see the answer, or you have to use use of. Alright, so y's need to come over here, x's need to go over there, right? So this is going to be 1 over y squared dy, sine of x dx. Right? Integrate both sides, integral y to the minus 2 dy, integral sine of x dx. Add 1, divide, negative 1 over y, yeah? On the left?
I think on the left side, the left one, usually the left one you have to just put in the, I don't know if it was the C that was screwing me out the way you entered it, or.
Oh,
you
that
don't have
one?
enough information on this to find the C.
I think they just, I don't know if it was like, which side the C goes on, or there wasn't a C on the left hand side.
Yeah, you put the C, generally speaking. Okay, technically, right?
C1.
Okay, and then on the right-hand side, technically speaking. However, now if I subtract the C1, then on the right I get C2 minus C1, which is C3,
Constant.
right? And so I generally just write the single C that would be, in my case, C3, and let it go. On the other hand, generally things are solved for y, and so if I do that, and I multiply both sides by y and then divide by c minus cosine x, then I am going to get negative 1 over c minus cosine x equals y. Now I skipped a few algebra steps right there, but that is most traditionally your final general solution answer, because you have isolated the y, which is historically, all the way back to pre-algebra, how we like to write our equations.
That's it?
Yeah. And I can't tell if you say that like it's a good thing or a bad thing. That is it.
Is that what you want us to do on the exam? Solve for y, or would you?
Yeah.
Didn't you say y equals 1 over cosine x plus c?
You could say y equals 1 over cosine x minus c. Okay, and then you could say the plus c, because then the c just being a negative is irrelevant. Yeah, but you cannot do
the
this.
C out.
No. This is part
I
of
thought you
it.
said only
Different.
roots.
Well, roots and fractions and grouping symbols. You can't pull them out of grouping symbols. And so you would not. I don't need this anymore. It is in my way. You could. Oh, goodness gracious. What is that? 1 cosine x minus c, right? You could do that. Where you distribute the negative into the denominator. Then you could say, well, c, I don't even know if it's positive or negative. So if it's the negative of this thing that I do not know, who cares? And so it is actually valid to write that, and you would be correct. A C can absorb a negative. But a C cannot be moved outside of a composition situation. This C is being composed with the 1 over x function, right? It's inside of a grouping symbol. It would be like it being inside the cosine and then deciding to pull it out. Nah, we don't need to take cosine of C, because cosine of C is just another constant. While that is true, it is altering the x before you get to the calculation of y. It's not the last step. And so moving it out changes it. Sean stayed after and asked a similar question about this, and how long, we spent, what, 20 or 30 minutes trying to come up with, I came up with an example that showed explicitly why this fails. I will try to briefly go over that explanation, but here's what you cannot do. Y does not now equal 1 over cosine of x plus C.
Oh no.
Oh, okay.
You can't do that. Okay? Here's the reason, in a nutshell. This is a relationship between x and y. It holds for an infinite collection of x's and y's, right? As x varies, you get different y's. They create pairs. They solve the equation. Life is good, right? For a given x and a y, some initial data, again, usually scientifically measured, you can find the C. If you're provided with an additional piece of information, you can find the C. That C was based on the x and the y that was measured, but it is valid for all xy pairs that solve the equation. And so as x changes, the plus C needs to give the appropriate y. If you take a C in this situation that was supposed to be in this situation, and you plug in your initial data, you will get a number that works for that x and y. But as soon as you find a different xy pair that should work, this C will no longer do the correct calculation. And so the pair that would normally have worked will fail. It will be a different C out here for each pair of x and y, rather than doing it correctly, giving you a single C that works for all pairs of x and y. And I could work out some explicit numbers and show you that, but I'm going to leave it at that for the moment, because I don't think it's important enough to spend that amount of time going into it. If you want more information on that and you want to play with some numbers, we can do that. But that's the situation. This C has a lot of freedom, but in the end, once you figure it out, it is a single C for an infinite collection of x's and y's, and that one C has to work for all of them. It's not a variable. It's an unknown constant. Those are very different things. An unknown variable that can depend on stuff, this doesn't depend on anything. It's fixed. It's unknown as of yet, but it's fixed for a given measurement situation, and it's got to work for all the x's and y's.
So,
That good?
so the plus C gives you like your family of functions when you're doing a directional field?
Yes.
I think I might have known that one. Okay.
It does.
I usually
That
don't
is
try to
absolutely correct.
that.
What's that?
I usually don't try to do anything fancy, so.
Don't do anything fancy. Okay? And if you're afraid of doing something fancy, label your C's.
That's me.
All right? If you are concerned, then this is C1, and this is C2, and this is C3. This is still C3, because I didn't actually change it at all. I just rearranged it. This is C4,
Huh?
because it's now the negative of what it was here. This is a different C, because now it's the negative.
Oh, because it ate the negative.
It ate the negative, and it became a different thing. And then this is just wrong.
It's not
That is not C5. That is just wrong. You cannot do that. Even if you claim it's a different C, it fails. Okay? Alright. Questions? Those who've been waiting patiently, stepped in a few minutes late.